Good afternoon and welcome to this afternoon's webcast, Exposing Risk in Your Electrical Safety Program. Thanks for joining us. I'm Bob Evra, Content Manager for Plant Engineering, and I'm happy to join you today on behalf of Plant Engineering and CFE Media for what we know is going to be a great afternoon of knowledge. Plant Engineering has met the standards and requirements of the Registered Continuing Education Program. Credit earned on completion of this program will be reported to RCEP at rcep.net. A certificate of completion will be issued to each participant. As such, it does not include content that may be deemed or construed by RCEP to be an approval or endorsement. Ensuring the prevention of injuries from electrical hazards involves continual assessment of risk and effectiveness of your electrical safety program. Are you aware of the latest developments in regulation, code standards, and technology impacting your program? Do you know who's at risk of injury? And what's the best measure of effectiveness of your program? Whether you're just starting to develop or have a mature and robust electrical safety program, today's webcast will help you identify gaps and opportunities for improvement in prevention of electrical shock and arc flash hazards. Among our learning objectives for today, we'll be describing the top 3 scenarios for exposure to hazardous electrical energy. We'll be describing the categories of workers exposed to hazardous electrical energy. We'll apply the OSHA recommendations for safety and health programs to identify gaps in electrical safety programs, and we'll look at some of the leading indicator metrics for prevention of electrical injuries. This afternoon's event is a live educational webcast presented on June 11th, 2019, and the educational category is Technical, Health, and Safety. Here's some tips to help you get the most out of today's webcast. If you're experiencing issues with your slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of this webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you're having technical problems with audio or the slide presentation, click on the question mark at the top right-hand corner of your screen to access a list of system checks to try before contacting an online technician. If you do need a technician, type a message into the Ask a Question box and someone will get to you as quickly as possible. You can type questions for our speaker in the Ask a Question box on the left-hand side of your screen, and the Q&A session will begin after the presentation concludes. To download a certificate of completion and a PDF copy of this presentation, use the Event Resources tab on the left-hand side of your screen. Those documents also will be available with the on-demand version of this webcast. We couldn't be happier to have our good friend and the guy I consider to be the leading expert on electrical safety in the country to be working with us today. Lanny Floyd is a Life Fellow at IEEE. He's the owner of Electrical Safety Group, Inc., and he's a member of the Plant Engineering Editorial Advisory Board. Lanny's also an adjunct professor in the Advanced Safety and Engineering Management Graduate Engineering Program at the University of Alabama at Birmingham. He retired from DuPont in 2014 after a 45-year career devoted to the prevention of electrical injuries and fatalities. These are always tremendous webcasts, a tremendous amount of information. Our attendees today are in for a great treat, and without further ado, your presenter for this afternoon, Lanny Floyd. Lanny?
Thank you, Bob. I certainly appreciate the opportunity to share some of my experiences with your audience today. I really appreciate the fact that Plant Engineering has been such a strong advocate for bringing knowledge and education to plant engineers and members of the Plant Engineering magazine community. As Bob mentioned in my introduction, I worked for the DuPont company for 45 years. And most of that 45 years, I was focused on how can we improve our electrical safety program that we use throughout the company. During my career with DuPont, we had a workforce of about 100,000 employees and contractors working at about 150 industrial and manufacturing sites in close to 80 countries around the world. So we had a very diverse exposure to electrical hazards, different types of work environments, different countries, different national standards and that sort of thing. But what we were able to do is have a very common electrical safety management system that we used on all of our operations. That particularly came to fruition in the mid-1980s. In this chart, I'm very proud of the results that we were able to achieve in DuPont in bringing attention to risk of electrical injury and putting in place some very robust practices and systems to assure that all of our workforce and our contractors were up to speed on understanding electrical hazards and the risk of electrical injury. Now, in this chart in the center, it just shows a trend of the electrical injuries, electrical fatalities from 1940 to recent years. And you can see when I started with DuPont in the late 60s and through the 70s and 80s, we were experiencing an electrical fatality about 1 every 33 months in our global operations. Again, for a workforce of about 100,000 people, that was industry average at that time, in that period of time. Now, DuPont was a world-class leader in safety, and when we realized that we were only average in preventing electrical injuries and electrical fatalities, I was very privileged to work with a group of people who felt that we could make a difference, and that wasn't satisfactory. So we worked very hard. We engaged management support, engaged our workforce, not just our electrical workers, but all of our employees and contractors. We worked very diligently with to change how they viewed the risk of electrical injuries and fatalities. And you can see in the bottom 2 lines there, in my first 25 years with my career in DuPont, we had 12 electrocution fatalities. In my last 20 years, we had 0. So we have results that demonstrate that the work that we did to change how we thought about electrical hazards and the risk of injury from those hazards had a big impact in helping us achieve breakthrough performance improvement. Now, what I'd like to do today is just spend a little over a half hour talking about some of the lessons that I learned over that period of time in how we viewed risk of electrical injury. So here's the agenda. I'm going to talk a little bit about what do we mean by compliance-based approach to to safety management versus a risk-based safety culture. We'll talk a few minutes about that, and then I'm going to talk about 5 I'll call common traps, pitfalls, where you can expose risk that you may not be aware that you had, and then you can work to reduce that. Maybe you can prioritize or change how you approach certain things. So again, no matter where you are on your program, whether you are just getting started, whether you're halfway there, or you feel you have a very mature electrical safety program, one of the key things about a risk-based approach to safety is that you're never satisfied with where you are. You're always looking for risk that may be hidden or undiscovered in the past. So let's get started. Some of the common risk traps. Well, the reason we want to do that, if you look at what OSHA has said over the last decade, this was a statement from the Assistant Secretary David Michaels. This was a communication to the OSHA staff back in July of 2010. And in the letter, he had this statement. He said that ensuring that American workplaces are safe will require a paradigm shift, with employers going beyond simply attempting to meet OSHA standards to implementing risk-based workplace injury and illness prevention programs. So that's a recognition that just being in compliance with laws and regulations, codes, and standards isn't enough. In order to really achieve a maximum potential or maximum ability to prevent injuries and fatalities requires this risk-based approach that is about constantly looking for risk and putting in place programs or interventions to reduce that risk. You're never satisfied. One of the things OSHA has done recently is in 2016, they updated the 1989 guidance for safety and health programs. In 2016, they published this booklet, but more than the booklet, there's an entire website dedicated to helping employers and workers understand how to continually assess their safety programs and to look for opportunities to improve it. Now, the 2016 update did some things to align the original 1989 guidance to conform with safety management standards that have been published since 1989. That included ANSI Z10, that's the American National Standard for Occupational Safety and Health Management Systems. That was published in 2005. OSAS 18001 is based on a British standard that was first published, I think, in the early 90s. Military Standard 882 is the safety management system standard that much of the military and Department of Defense use. Many defense contractors, because they're aligned with their military counterparts, also use 882 as their safety management standard. That's one of the oldest safety management standards, by the way. It's first published in 1969, and it's been updated a number of versions. Version E reflects the revisions since the original publication. Most recently, the ISO 45001, which has also been adopted by ANSI. It was published in 2018, just last year. Now, the reason OSHA published this document, recommended practices for safety and health programs, is that these other safety management standards really, for the most part, require competency in safety management systems. In other words, a dedicated safety professional that are educated and certified in understanding what we mean by safety management systems. And so this document and the resources on the accompanying website target small companies with limited safety management resources. So it's written in a much easier to read method, and also provides guidance that are then in language that's more user-friendly rather than just the standard-based language approach. So again, a very significant resource from OSHA, again supporting the focus on shifting our culture, not to be just in compliance with standards, but also to have a very risk-based approach. So if we look at the trend in electrical fatalities in the U.S., this goes back to the around early 80s, I believe, to recent years, we can see that over the years we see a downward trend, which is very good. There's been ups and downs. Some of that is due to the economy, whether we're having a lot of construction work activity going on, or we're in a recession and a lot of work is being postponed or deferred. So the question is, how good is this? Is that good enough? If we look at recent years, this is from 2000 and 2016, looking at the trend in occupational fatalities in the U.S., we can see it's very flat when we look at the detail. So there's one of the concerns in safety management today in the U.S. is that not just in electrical safety, but in all hazards in the workplace, the trend in fatality prevention has flattened significantly. So there's been a lot of questions raised, and what can we do differently to change this? Can we get even lower? Well, to answer that question, we need to look outside the U.S. and look at how other countries are managing risk from occupational hazards in the workplace. And we see that in Europe, fatality rate in workplace safety is significantly less than it is in the U.S. In fact, for what I have outlined in red here on the chart on the right is the fatality rates from contact with electrical energy. And the U.S. fatality rate is 3.8 times greater than it is in the U.K. and is greater than it is for most of the Western European Union countries. Now, this data came from the paper there showed on the left, the occupational fatality risk in the United States and the United Kingdom. This was published in 2014, so this is fairly recent data helping us understand that there may be opportunity for us to improve not just electrical safety, but occupational fatalities in the broad sense here in the U.S. Now, why are they different? Well, Fred Manuel, who's the photograph here on the right, is one of the leading authorities in safety in the world today. He's based in the U.S., and he had this quote in a recent article that he published. He said that the risk assessment is the cornerstone of the European approach to prevent occupational accidents and ill health. If the risk assessment process, the start of the health and safety management approach, is not done well or not done at all, the appropriate measures are unlikely to be identified or put in place. Now, tie Fred's quote here with what we saw from Director Michaels just a few slides earlier, where Director Michaels was saying that in order to improve occupational safety in the U.S., we need to shift more towards a risk-based approach. Again, we've seen the results in Europe, in the European Union. So what's the difference between U.S. and U.K.? Now, the answer is not this simple. This is a very simple illustration, but if you look in, if you could boil it down to just a few words. Here we see a collage in the center. These are codes, regulations, and standards that most of us should be very familiar with related to electrical safety. We have OSHA regulations, we have the National Electrical Code, we have the National Electrical Safety Code, we have NFPA 70B, which is on maintenance, we have IEEE 1584, which is the arc flash hazard assessment protocol, we have IEEE standards on maintenance and safety, and we have NFPA 70E, a premier standard on workplace safety in the U.S. and other countries around the world. So we see a little character on the left-hand side and the American flag, and he's representing an American worker. He's saying, I follow the rules. I know what the rules are, and I follow the rules. The character on the right has his magnifying glass, and he's adding a perspective from the UK. He says, yeah, we need to do that. We need to follow the rules, but I also look for risk. After we comply with the laws and regulations, have we missed anything? Or is my workplace environment, do we have risk that the codes and regulations maybe don't quite cover as we would like for them to? So let's get into some of the opportunities to expose risk in our electrical safety programs. Here are 3 questions. Who are the workers at risk from electrical hazards? Does your electrical safety program cover all those workers? And what are the workplace scenarios with the highest risk? We'll look at these 3 questions first. So who's at risk? Well, we see in the photograph here electrical workers who are working on or near hazardous electrical equipment and systems. They certainly are at risk. But there are other workers. Here we see in this photograph, we have a crew that's moving a large piece of equipment down a public highway, and we're coming in contact unintentionally with an overhead power line. So we have workers who may be coming in contact with overhead power lines, and that could be crane operators, truck drivers, agricultural workers, scaffold erectors. The list goes on and on. We'll get into a little more of that in a few minutes. And then in this photograph, we have a groundskeeper or landscaper using an electrically powered leaf shredder. So he's representing workers who use portable electrically powered tools. So when you think about who in the workplace uses portable electrically powered tools, that could be a lot of people, especially if you consider appliances and other cord-connected devices that are common in workplace. That includes things in your office. It could be out on the manufacturing shop floor. It could be anywhere, out on the construction site. And then we have a group of people that are exposed to unguarded electrical energy. And we have a photograph here of an electrical panel with the cover off. Well, that could be an electrical outlet with the cover off or the cover broken. Or it could be an appliance with an access cover loose or missing. So we would have workers, employees who are exposed to unguarded electrical energy. So who's at risk? What I've seen, a common pitfall is that organizations have designed their electrical safety program around electrical workers. The workers whose job description calls out for them to be working on or near hazardous electrical energy. Well, that certainly is one group of employees that are exposed. But then we have a whole list of others. We live in an electrical world today. Everything we do utilizes electricity and electrical energy in some form. We have lines, power lines, cords, wires, equipment all around us. So we have construction laborers, groundskeepers and landscapers, truck drivers, crane operators, painters, farm workers, managers and supervisors, and the list just goes on and on. Almost everybody in the workforce today, to some degree, has exposure to electrical hazards. Certainly, it's different depending on your job activity or job description. Certainly, people who work in an office don't need to be trained on perhaps arc flash hazards, but they do need to be aware and trained on hazards associated with cord-powered equipment. Okay? Okay, here's another trap. I've seen many organizations transfer most of their risk to electrical hazards to competent and qualified contractors. If you have an organization where you're focused on a particular business operation and electrical maintenance or electrical construction is not your expertise, then it's not uncommon for organizations to contract that out. But you need to be careful and don't fall into the trap where you think that we don't do electrical work. Let's look at some of the details here. 50% of the fatalities in the U.S. from contact with exposure to electrical energy involve contact with overhead power lines. Most of the victims are not electricians or linemen. And we saw that list a little bit earlier. We have carpenters, painters, window washers, crane operators, truck drivers, people carrying ladders, people carrying conductive, long pieces of conductive parts, such as metal siding or gutter or other roofing materials. We have anything that's conductive that could come in contact to an overhead power line, whether it's something portable like a piece of pipe or something like mobile equipment like a crane or a truck. So we have that. So even if you're contracting out your electrical maintenance construction, you may still have some exposure to overhead power lines. Now, about 35% of fatalities in the U.S. come from electrical hazards from contact with or exposure to electrical energy involve workers whose job responsibilities include working on or near unguarded energized conductors and parts. And that's typically the workers that we call electricians or linemen or electrical technicians or something along that. That's about 35%. So 65% of the fatalities and injuries fall outside that job description. So again, you need to think about what exactly, if we don't do electrical work, do we still have electrical exposure? Now, about 15% of the fatalities come from contact with or exposure to electrical energy involving workers using cord power tools and appliances and temporary extension cords. That could be out on a construction site, that could be maintenance workers, that could be cord-powered equipment in your vending area or your lunchroom. It could be cord-powered equipment and tools in your office. or in the shop or anywhere. So again, there may be risk associated with that. And even if looking at it a little bit broader, about 24% of industrial fires are attributed to faulty wiring or faulty electrical equipment. So don't fall into the trap of saying, well, we don't do electrical work, therefore we don't have any exposure to electrical hazards. You likely do. You need to think about what is your risk. Now, one of the most important safe work practices when working on or near energized electrical equipment is to establish an electrically safe work condition. And that's when you identify the sources of power, operate isolation devices, lock them out, verify isolation with testing and so forth, and you may even apply temporary grounds on certain equipment. So what I've shown here on this slide, in the center is the little character holding a plug. That's representing an electrical worker, a worker that's the electrical safe work condition has been established, but we need to be careful. There may still be risk. Now, I put three of these words or groups of words in red, and that's for a reason, because they are sources of electrical energy, even though you may have an electrically safe work condition. For example, in the upper right, on the line side of each of the isolation devices, there's likely electrical energy. We need to be aware of that. We need to be conscious of that. We need to make sure that we stay sufficient distance away from that so that we don't get tangled up in energized line side. And I've seen many accidents where, unfortunately, due to the distractions listed in these other words around this guy, we end up making a mistake. Now, the other two terms that are in red text, down at the very bottom, we have nearby circuits. Even though your circuit you're working on may be an electrically safe work condition, there may be other circuits nearby, maybe outside the restricted approach boundary, but or is nearby and could present a risk to workers if we forget where the safe work boundary is. And the other term I have over in the lower left are covers and shutters. This is covers on electrical equipment, so maybe switch gear. Could be shutters. Shutters are commonly used in draw-out circuit breakers, low voltage and medium voltage circuit breakers. And so there may be energy, hazardous energy, behind covers and behind shutters, and we need to be aware that to make sure that we understand that we can't take off any covers or raise or open any shutters that could expose workers to electrical hazards, because if you were to open the door or remove a cover or lift a shutter, you're immediately in very close proximity to hazardous electrical energy. So in these other terms around here, I won't read them all, but these are things that contribute to people making a mistake. Time pressure, poor lighting, poor workspace, weather conditions, the cell phone rings. We have improper tools. We have PPE that's limiting our dexterity or visibility. Maybe the equipment is damaged. Maybe the drawings are incorrect. Maybe we have personal health issues. Maybe there's a tripping hazard. Maybe labels are missing. Those are some of the things. And this, the terms I have listed around here are just some of the terms, some of the things that contribute to enabling a person to make a mistake and maybe allowing them to drift into a danger zone, even if you have an electrical safe work condition established. So you need to look at that. You need, anytime that you have an electrical safe work condition, you need to make sure people understand the boundary, and you think about what could enable a person to get outside that boundary, and put in some interventions to reduce that likelihood. Here's another trap. We've never had an electrical injury here. Well, that's not too unusual. If in this pie chart, we have a pie chart showing non-fatal lost time injuries in the U.S. This is from a few years ago, but we see that the large segment there, 1/3, are sprains, strains, and tears. These are non-fatal lost time injuries, so a person required hospital treatment. Down at the bottom, we have musculoskeletal disorders, about 1/4 of the total lost time injuries in the U.S. And then over on the right in the green, we have falls on the same level. Someone, for example, trips on a carpet or trips on a cord and falls on the floor. They're falling on the same level. Those three hazards alone account for about 3/4, 75% of all the lost time injuries that occur each year in the U.S. At the very top, you can't even make it out in this chart, there's a tiny sliver of red, and that is the electrical shock and burn injuries, arc flash burns and electrical shock burns, non-fatal, that occur in the U.S. each year, less than 0.2%. So if you feel like you haven't had an electrical injury in memory or in a long time, it may or may not be due to the quality of your electrical safety program. It may be due to the fact that these just don't happen very often, okay? And so don't get caught into the trap that we've never had an electrical injury, therefore we must be really good at preventing them. That may not be true. Electrical injuries are very, very low frequency. About 1 out of every 500 lost time injuries is an electrical injury. So if you look at the number of lost time injuries you have in your organization each year and think about 1 out of 500 would be a lost time injury, then you can understand why we haven't had one in a long time. But they are very high consequence. There are very few minor injuries involving contact with electrical industry. About 1 in 13 lost time injuries from electrical exposure is fatal. Currently in the U.S. is the 6th leading cause of occupational fatality. And if you're in the construction industry, or if you have construction contractors working in your business or your facility, building a new project or whatever, you need to be aware that contact with electrical injury is the 2nd leading cause of fatality in construction. So if you've never had one, don't wait for the first one before you get the motivation to prevent the next one. You need to prevent the first one, all right? Again, that's a very significant risk, is thinking that we've never had one, so we must be in good shape. Okay, another risk, another pitfall, is the failure to integrate the relevant codes, regulations, and standards into your own unique, customized electrical safety program that you use in your facility or your company or your organization. The pitfall that I see many people do is think, we comply with all OSHA regulations, or we use NFPA 70E for electrical safety program. The regulations and the standards are not an electrical safety program by themselves. They are there to provide you guidance on what your program needs to contain, and it's more than just what's in any one code, regulation, or standard. Here I'm showing, again, that collage of OSHA regulations, the National Electrical Code, which covers the minimum requirements for installation. If you have overhead power lines on or near or around your facility, the National Electrical Safety Code is a regulation that is relevant. We have the IEEE 1584 is the guidelines for conducting arc flash risk assessments. We have IEEE standards on maintenance and safety for industrial and commercial power systems. We have NFPA 70E, again, a very prominent standard in workplace electrical safety. They provide the input that you need to incorporate into your electrical safety program. And this is where I see many organizations fall short. You just can't say that our program is a standard like 70E or OSHA regulations. Those regulations, codes, and standards provide the minimum requirements. You need to take those minimum requirements and integrate it into your own electrical safety program. I think this is the last pitfall that I'm going to be talking about. I've got several slides on this, and this is a failure to or missing the boat in the evolution in inherently safer technology. Now, the first slide here is a rather extreme example, because in the photograph on the left-hand side, we see a live front unenclosed switchboard, which was common and standard at least through the 1920s. Some of these were installed even later in the U.S. and other parts of the world. And we see a worker standing in front of it. And so that worker's safety is dependent on them knowing what not to touch on the front of that panel board, because there are live conductors, switches, fuse blocks, terminals on that switchboard. Now, over on the right-hand side, we have a more modern dead front enclosed switchgear. Much of the equipment that we install today is fully enclosed, and as long as the doors are closed, covers are on, most workers are not exposed to electrical hazards. So we have, again, an illustration here that shows that technology has changed during the 20th century and going into the 21st century to reduce the risk of exposure to electrical energy. Now, electrical equipment, much of the industrial and commercial equipment stays around for a long time. It's not unusual for switchgear, transformers, motor control centers, switches to be around for 20, 30 years. During that time, the evolution in inherently safer technology has marched forward. And if your equipment that you have installed may not have all of the inherently safer design that you could achieve today if you were to install it today. So there is an opportunity to reduce risk. Is there risk that is there significant risk you could reduce through better, more modern technology? And I've got a couple examples here. Now, most of us have lived, at least I remember, back before 1962. Many of you on the webcast today don't date back that long, I know. But prior to 1962 in the U.S., the outlets that we had in our homes, in our businesses, and in many industrial facilities were the two slots here that are seen on the left. In 1962, the National Electrical Code codified the requirement that all new outlets have the equipment ground, the third wire, and that is to assure that everything that's plugged into that outlet, that if it had a metal case, that the metal case of the portable tool or appliance was grounded, so that if you had a failure of insulation, the case would not become energized and someone could be electrocuted just by touching the case of an appliance or a tool. Now, in 1970, that technology was raised to an even higher level with the introduction and requirements for ground fault circuit interrupter outlets and circuit breakers that followed. Today, we have other technology that looks at different hazards, such as the arc fault circuit interrupter outlets and breakers. So again, these are representative of the evolution. If you look hard, in some organizations and facilities, you will find opportunities to improve the equipment grounding protection, either through the three-wire grounded outlets or the GFC outlets. There are still opportunities in older facilities to do that. The code doesn't require it. The OSHA does not require that you update to meet the current code, but the opportunity is there if you see that you have risk that you want to reduce. Related to that is the evolution in double insulated tools. On the right-hand side is a right angle drill that has a insulated case. This was purchased about 2014, has a non-conductive case. It does not have the 3-wire grounded because it's not necessary, because if you have an insulation failure inside the tool in the motor or in the switching mechanism, the insulated case prevents the energy from coming in contact with the person who would be holding this tool in their hand. That's compared to the very similar tool on the left-hand side. This one was purchased in 1974. It has a conductive metal case and a 3-wire cord. Now, if the 3-wire cord is plugged into a 3-wire outlet and everything is intact, there's no broken equipment ground, the 3-wire outlet has been installed properly. If you have a failure in the insulation inside the tool, then the cases will be grounded, and so you're not exposed to electrical energy. However, if you have a failure in the cord, if the equipment ground is broken, if the third equipment ground prong is broken off, if it's plugged into an extension cord that has a defective equipment ground, either a broken wire or a broken off prong, then that safety feature does not exist, and you could be exposed to a serious electrical shock incident. So the newer non-conductive double insulated tool on the right-hand side, the yellow one, is an example of the continuing evolution in inherently safer technology. Here we see a comparison of the cord plug on the end of a cord-connected piece of equipment. In both of the photographs, the plug in the top left is from the 1950s. There's no, you see exposed wires on the screw terminals there. You can see where on the right-hand photograph, you can see how the fingers are touching the plug in, and so the fingers are much closer to energized parts than they are in the more modern plug that's in the lower right in both of these photographs. So again, example of inherently safer technology. Do you have any old equipment laying around? Do you have any equipment with old cords and old plugs that maybe don't have these features built into it? May be an opportunity. Here's one more. This is illustrating some of the smart equipment that's available today. Motor control centers, substations, switchgear are available today that have communications technology. So instead of troubleshooting in a traditional way, like the two electricians dressed out in arc flash and shock protective equipment there on the right, they're doing troubleshooting in a motor starter. The technician on the left, in the left photograph, is doing basically the same troubleshooting technique. He's obtaining the similar information, but he's using his laptop plugged into an Ethernet connection in the front of the motor control center. So he's doing the same type of troubleshooting, but without exposure to hazardous electrical energy. So again, an example of the evolution in inherently safer technology. Here's one more. This is comparing two different fuse blocks. These are 250-volt fuses. The fuse block on the left is a more traditional design. It's been around for a long time, very common. You can see the energized parts are fully exposed. The fuse ferrules, fuse clips are there. You have to be careful when you're working around this. You have to be careful and don't touch it, all right? The fuse block on the right is designed with all the energized parts shrouded or covered, so that if you were working on or near that fuse block, or if you even wanted to change a fuse, replace a fuse, it can be done without exposure to electrical hazards. All right? Again, so the question here is, which fuse holder is more effective in reducing the likelihood of an electric shock during routine maintenance for the lifetime? This could be in place for 25, 30, 40, maybe even longer, 40 years or longer. This is an example of inherently safer technology that was required in the 2008 National Electrical Code. And this had to do with reducing the risk of disconnecting ballast in fluorescent light fixtures or other fixtures that luminaires that had ballast type of devices that may need replacement from time to time. The requirement is in the upper right-hand corner of this photograph are the touch-safe disconnect device that allows an electrician to disconnect the ballast without having to turn off the power to the circuit. And that was the challenge that was being faced prior to this requirement, is that too often people were making the decision to disconnect the twist-on wire connectors, as we see in the lower right photograph, without disconnecting, without de-energizing the circuit, just being very careful to not touch anything energized. That works a lot of times. Unfortunately, for a number of electricians, it did not work. And so the touch-safe disconnect is an example of inherently safer technology. So in recap, again, this has been just a few of the traps that I've seen over the years that, you could ask, do we have these in our organization? Does our electrical safety program address these traps? Are we confident that they do? I talked about the excluded workers, failure to integrate codes and standards, the belief that we don't do electrical work, the trap of thinking that we've never had an electrical injury, so we must be really good at preventing injuries, and also the last one I just covered, missing the boat and the ongoing evolution in inherently safer technology that reduces the risk of exposure to electrical hazards. I'd like to leave you with this quote. It's from Warren Bennis, who's a management consultant. When you're thinking about what do we need to do differently in our electrical safety program, we need to be careful. Don't go with the herd mentality. Just because everybody's doing it this way, it doesn't necessarily mean it is the right way or the best way. Here's what Warren Bennis said, and he wasn't talking about electrical safety. He was just talking about excellence in general. He said, excellence is a better teacher than mediocrity. The lessons of the ordinary are everywhere. Truly profound and original insights are to be found only in studying the exemplary. So when you're thinking about working on improving your electrical safety program, I would urge you to be careful and make sure that you're looking at examples and resources that are truly extraordinary, the exemplary. Some resources that can help you do that. Again, I mentioned the recently published OSHA resource on recommended practice for safety and health programs. There's nothing in this that is specific to electrical safety, but it is the underlying framework for managing and reducing risk in the workplace. Again, you can Google, do an internet search for OSHA recommended practice for safety and health programs, and you'll not only get this publication, but you'll get to their website that has a wealth of information that can help you look for opportunities to reduce risk in your operations. I have been attending the IEEE Electrical Safety Workshop for the past 26 years. It is a forum that is focused solely on advancing the practice of electrical safety and advancing the electrical safety culture. Many of the improvements in advancing inherently safer technology has grown out of discussions and conversations that occur at this workshop. Many of the latest technology from equipment manufacturers are introduced at this workshop. It's just a forum for learning from others. And the next one is coming up in March of 2020 in Reno, Nevada. So if you're interested, just do an internet search for ESW 2020. And the Electrical Safety Foundation International has a wealth of information to help you educate not just workers, but management, supervision, safety professionals, your training staff on electrical safety hazards, electrical safety risk. There are videos, posters, booklets, brochures, and most of that is free. Unless you order in quantity, then you may have to pay a nominal charge, but most of the information is available just as a download. A great way to to boost your knowledge around electrical safety. So that was my last slide. So Bob, I'll turn it over to you, and I think we may have some questions.
Absolutely. Thanks so much, Lanny, and it's always a great presentation, and we're looking forward to getting to some of those questions. If you've got questions for Lanny, type them in the Ask a Question box on your screen, and the questions we don't get to today will be answered via email within a week. And to download a certificate of completion and a PDF copy of Lanny's presentation, use the Event Resources tab on the left-hand side of your screen. At the end of our webcast, we'll have an exit survey that'll pop up on your screen. Please take a moment to fill that out as we use the answers to help make improvements to our webcast program. Within 7 days, an archive of this webcast with a Q&A will be posted at planengineering.com. You'll get an email as a registered attendee with a hyperlink to that archive version. You can also access the webcast and all of the webcasts that Plant Engineering produces on our homepage at planengineering.com. And for continuing education on a variety of topics, including electrical safety, visit CFE.edu at cfeedu.cfemedia.com. So let's get to a few of the questions here this afternoon. You talked about the differences kind of between the U.S. and the U.K. and more of a risk analysis in the U.K. What do you mean by risk-based safety culture?
Yeah, that's an excellent question. A risk-based, excuse me, a risk-based approach is not about accepting risk, but it's about identifying and reducing risk. In other words, as I illustrated, or hopefully I pointed out, you can comply with the laws and regulations, but even if you do that, there may still be opportunities to further reduce risk from exposure to electrical hazards. And so it's about not being satisfied that doing the minimum is good enough, but it's about continually looking for opportunities to reduce risk. That's a very simple description. In practice, it's much more complicated than that.
Yeah. Excuse me. Let's talk about, we talked a great deal about codes and standards. What were some of the top code changes last year in NFPA 70E, and how does the code enforcement and the code process, which is a continuing effort, it doesn't stop just at 1 year, but what are some of the key code changes, and what's a practical way to stay on top of this and also to start to implement some of these within your facility?
Well, certainly one of the changes that has occurred in 70E over the last 2 cycles has been the enhanced focus on conducting risk assessments. And that's a part of a risk-based approach. The risk assessment, whether it's conducted very broadly by the employer to look at risk of exposure to electrical hazards in the workplace, or it's done by the worker who's standing in front of a piece of switchgear and want to make sure they understand where are the hazards in this gear and what do I need to be doing to reduce my risk and control my risk while I'm doing my work today. I mean, those are all part of it. Now, one of the questions I saw was, does OSHA require us to do risk assessments? That's a bit of a fuzzy answer on that one. If you look at the underlying fundamental objective requirement from OSHA, the general duty clause, and that is that the employer is required to identify and reduce risk in the workplace, to provide a workplace that is as free of hazards as possible. Certainly reducing risk to zero is not possible. There's always risk associated with anything we do. Our goal is to reduce it to as low as we can, as low as acceptable, and that's what OSHA requires in the general duty clause. Many people, unfortunately, think that just to being in compliance with the safe work practices of for example, the electrical safety work practices and Subpart S, or you look at other hazards in the workplace. Just being in compliance with the law isn't good enough. An example, a corollary would be driving down the highway. Just being in compliance with the speed limit is not enough. We've got to be concerned about has my vehicle been properly maintained? What's my competency as a driver? What's the competency of everybody else on the road? I mean, those are those issues. That's beyond the regulatory requirements. Okay. Again, that could go on for a long time talking about that, but that's a brief answer there.
Yeah, and Lanny, we've talked about this on many occasions. The short way of saying all that is that you can do all the risk assessments you want, but you can't legislate stupid, and you can't legislate careless, and you can't legislate that things break sometimes.
Well, that is true. That is true, and sometimes we feel that if we're in compliance with the law, it's an illusion that we've done everything that we need to do to protect ourselves or protect our workers.
And it's a continuing training process. It's a continuing awareness process, and
right.
And something that we've talked about for a long time in this area. I've got a question in from Jim Walker at Simpson Lumber. What are the opportunities available to improve grounding in industrial facilities with 480 Delta electrical distribution and equipment?
Well, I'm assuming that we're talking about 480 volt Delta secondary, that it may be ungrounded. There are opportunities well, let me back up. The ungrounded Delta systems were common back in up through the 1950s. It was thought that that would not only improve be safe, but also achieve the reliability of your operations. The experience with the ungrounded systems found that they weren't as reliable as we perhaps thought they were, and it created some other operating difficulties. I won't go into the details of that, but the grounded Delta and grounded Y, center grounded Y, became the standard in the 70s, 80s, and through today. What is becoming more common today is high resistance grounding, and that can be done on center grounded Y systems. On some of them, there are some issues that you have to avoid around line to ground loads, and also but going to the question on the Delta grounded or the Delta 480 volt systems, there is some technology that you can use to create a grounding point for those Delta systems. I will work closely with one of the big. I would work closely with a knowledgeable supplier, either the manufacturer of switchgear and equipment, or engineering services that are competent in industrial power system design. There are solutions to that issue that can improve safety and reliability.
Very good. Now let's end on this note. How do we measure the effectiveness of an electrical safety program beyond the obvious mitigation of incidents? What are some of the other few key indicators for an effective electrical safety program?
Well, one of the leading indicators that is talked about a lot, not just for electrical safety, but in occupational safety in general, as we were trying to shift our culture more to a risk-based approach, is measuring and monitoring how well are we doing in identifying opportunities to reduce risk. This is leading indicators. An example could be in audits or design reviews. How often do we find opportunities to reduce risk? In electrical incident investigations, say in close calls, near misses, where no one was hurt, but we could have had someone. Where do the recommendations lie? Are the recommendations focused on reducing risk through engineering design changes to the system or equipment, or are they focused on more training and more PPE? And that more training and more PE does not necessarily get at the root cause of the problem. The engineering design solutions are long-lasting and have much more effective in reducing risk than depending. Now, I'm not saying that training and PPE is not important. They are very important, but they're vulnerable to human error in understanding, knowing, responding, doing the right thing every time, exactly right. Engineering design solutions, such as the metal enclosed switchgear I talked about, the double insulated tools I talked about, the GFCIs that I talked about, the touch-safe fuse block I talked. Those are examples of engineering design solutions that takes the risk out of the hands of the worker, and they're built into the design of the equipment. So you're not depending on that worker to have to be safe all the time. Okay.
Very good. Well, that's great, Lanny. Again, our thanks to Lanny Floyd for once again sharing his tremendous expertise on the area of arc flash and electrical safety. And now that we're just about done, we want to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. So please take a moment to complete it as we use this information to improve our webcast. So on behalf of Lanny Floyd and on behalf of Plant Engineering, I'm Bob Avra. Thanks for attending our webcast this afternoon. Thanks, and have a wonderful afternoon.